Hello everyone, welcome to my channel Chemistry by ANR. We are going to discuss about meso compounds and we are going to practice some of the application based questions. This first compound which I have given you, along with this I gave two questions. Does it have an enantiomer? Can you draw the mirror image? So to answer these questions, I have again drawn the structure. So here we can see that this compound has two chiral centers. These are the chiral centers. If we see the first chiral center, around the first chiral center, if I say OH per CIP rule, if I say this OH is 1 having maximum priority as per maximum atomic number, then because oxygen is attached, right? Now carbon number, the second priority will obviously will be this. Why? Because it is this group, right? This compound, this carbon atom, it has this group, so this is number 2. Number 3 will be CH3 and number 4 will be H. So since H is number 4, this is the lowest priority group or LPG, the lowest priority group, which is in the horizontal position. And now when we see the priority sequence from 1 to 2 to to 3, we can see that it is coming in this manner, 1 to 2 to 3. So this is clockwise manner. And as per the CIP rule, if it is a clockwise manner, the configuration around the first chiral carbon should be R. But since the LPG, this hydrogen, is in horizontal position, it will get reversed and we have S configuration over here. Now in the other carbon, there again we can say that number 1 is this OH, number 2 is this part, number 3 is CH3 and number 4 LPG is H. So again this is coming 1, 2, 3 anti-clockwise manner, which needs to be S configuration. But since LPGH is in horizontal, as per the CIP, it gets reversed. And so instead of S, it is R configuration. Now, when you try to draw this mirror image, suppose I say this compound is the mirror image, but is it the mirror image? Is it the enantiomer? So for that, we need to see what is the configuration over here in the first carbon, which is chiral. We will see that number 1 OH, number 2 is this, number 3 is CH3 and number 4 is H. So H is in horizontal. So this is 1, this is 2, this is 3 anti-clockwise. Needs to be S, but since H, the LPG, lowest priority group, is in horizontal, it gets reversed. It is R configuration. So it is just the opposite. Here it was S, so this needs to be R. Here it is R, this needs to be S. But they are not enantiomers. They are not enantiomers. Because if I consider it to be the mirror image, having the opposite configuration, S becomes R, R becomes S. Yet the relation amongst them is meso, not enantiomers. They are meso compounds. Why? Because they are the same. If you notice the structure, it contains a plane of symmetry. See, it has a plane of symmetry. This is the plane of symmetry which I am drawing over here. This is the plane of symmetry. Why? Because this OH, here it is OH, here it is H, here it is H. Again, you can see this is methyl, this is methyl. So this plane divides the compound into two equal, identical parts. So this is the POS, plane of symmetry. Meso compounds either have a POS or it has a COS, plane of symmetry or center of symmetry. on account of which it is a chiral compound in spite of having chiral centers. It has two chiral centers, can have even more number of chiral centers, but if it has any internal element of symmetry, internal plane of symmetry or center of symmetry, it becomes a chiral, optically inactive, and it becomes meso compound. Since it is optically inactive, it does not rotate the plane polarized light. If I consider this compound, see, if this compound is seen, then if I draw the line in between, then on both the side of the line, the groups are not identical. If there is OH on the other side, there is H. So they are not the same groups. So this is not an internal line of symmetry. I cannot say this is POS. Why? Because it is not dividing the molecule into equal parts. It's not symmetrical. So this is not meso. This molecule is chiral. And so we can draw its mirror image. And what is the relation of this mirror image? They are enantiomers. Why they are enantiomers? Because they have no internal, they do not have any internal line of symmetry. So what type of questions can be set from this type of concept? The question I have given, identify optically active or optically inactive molecules. So for seeing any educational video, always be prepared with a copy and a pen. Why? You need to give pauses and draw the structures along with me, right? So these examples, this is 1, this is 2, this is 3, this is 4, 5, 6 and 7. You draw them by pausing the video, and then you see in each of the structure whether you have any internal line of symmetry. For that, we need to see them one by one. First one, this is your internal line of symmetry. This is the POS, for which this is a meso compound and it is a chiral, optically inactive. Second one, let us see what is there in the second one. This is the chiral carbon, and you do not have any plane of symmetry or center of symmetry inside the structure of the molecule. So, no POS, optically active. The molecule is chiral. See the third one. Third one again. See, I have drawn the plane of symmetry. Here is the POS. OH is here wedge. This OH is also in wedge form. Since both are same, then this is POS. Had it been one wedge and the other dash bond, then it wouldn't have been POS. Since there is POS, obviously this compound is meso. It is optically inactive. See the fourth one. One bond of Cl is wedge, the other is dash. So this is actually not POS, for which this molecule is not meso, so it is optically active. See the fifth one. This one is your POS. You have both the sides identical structure, so this is meso, optically inactive. Sixth one. In sixth one, you can see on both the side of the line which I have drawn, the red line cutting the structure into two parts. So, on both the side you have OH and OH, H and H. But on the top part you have CH3, on the bottom part you have CH2, CH3. They are not the same but different. So, this is not POS because both the parts are not identical. They are not symmetrical. So, it is not meso, it is optically active. The molecule is chiral. The last one, both the bonds are wedge on both the side of the line, which we can say now is the POS. So, since there is POS, the molecule is meso and it is optically inactive. I hope the concepts were quite clear. You can practice similar questions from the papers of competitive exam. So, bye all of you.